So we would like to say thank you so much for joining us today. We'd also like to say thank you to Women in Tech for inviting us to speak here to you today. So the theme of this conference is Space to Play. And we will for sure be looking at space. We will look towards the stars. We will explore new frontiers from a technical and from an innovation perspective. But we will also look inwards to our motivation. And Emma, what did make you go towards the tech kind of area? No, sorry, hold on. Wait with that, and we'll come back to the very end of this presentation, of this talk. So my name is Jenny Gardner, and I am a Senior Strategy Director for SAAB at the business area we call Surveillance, that work a lot with sensors and command and control, or what we would say in a commercial kind of speak, management systems. I worked at SAAB before as a head of strategy and portfolio for our combat systems, again, military management systems, you could call them. And I started almost 8 years ago working in the UK, setting up the whole of SAAB's research and development business in the UK. And I established something called the UK Innovation Hub. And I'm here working with new capabilities, which is basically around new solutions, mitigating threats. And Emma,
yes.
Please.
My name is Emma Berglund. I'm head of product unit Giraffe-1X at SAAB. So this unit is responsible for development, production and delivery of radar systems that I will talk a little bit more about later on. I've had different managerial roles within SAAB, always managing and leading technology development. So I'm really glad here today to be able to talk a little bit about how we work with technology development and to meet all of you who share that passion as well.
And before we get started, I'd like to do a shout out to Lynn Jakobsson. Where are you in the audience? Yes. Could we give Lynn a big applause? Because Lynn Jakobsson, she is our colleague, that's our true woman in tech. She's been organizing everything around SAAB's participation, and that Emma and I, that we are here.
Yeah. It's the first time we're here as well, so we're very happy to join the family. Yeah.
So first a couple of words about SAAB. So many of you know SAAB from before. We used to manufacture cars. We don't do that anymore. SAAB was actually founded in 1937, and that was to develop and manufacture combat aircraft systems. It was also about providing Sweden with a strong defense during very uncertain times. This was just before the Second World War. SAAB today, it's many years ago now, and we serve the global market with the leading products and solutions and services. We are very much focused on the military domains, which is air, land, sea, cyber, and space. But we also work with civil commercial solutions and security specifically then. So innovation is very central to SAAB. And we have about 24,000 people, employees around the globe that works with both our products but also quite a big part with innovation. But in all of this, we deliver our products on the basis, which also comes back to the purpose that the company was founded in 1937, and that is to keep people and society safe. You recognize a couple of our products on this PowerPoint kind of presentation. We have 5 core areas, that's what we call them. So we have quite a lot of products, but we divide them into core areas of basically technology development. First, we have our fighter systems, and there you'll recognize maybe our flagship product, Gripen. So we are one of the few countries in the world that we manufacture our own fighter jets. We have our underwater systems. There we have the submarine, for example, A-26, but we also design and build, for example, corvettes. We have quite a broad portfolio, and Emma specifically, she's going to talk about the sensor side of our business. We work with command and control, which I've been working with quite a lot, as I mentioned. And then we have our advanced weapon systems. So that is basically our core areas with the type of technology we work with.
Yeah. And as I think many of you are aware of, the defense industry is right now in a very intense setting, and a lot of things is happening. It's a rapid transformation. It's driven both by geopolitical trends, but it's also driven by technology. A lot of new technologies are entering this industry. AI is being implemented in the products. We see more and more autonomous and manned systems. And we also see that we go more and more to distributed smaller sensor systems that are connected and can share data and information. All of this innovation and technology development is happening right now in the battlefield. It's also happening by new entrants coming into the industry and the market. And as a player that has been here for a long time, it's really crucial for us that we continue to work with technology enhancements and that we work with innovation to ensure that our products and our capabilities creates value and help us to keep our society safe. So today we will showcase some of these technologies that we are working on.
Thank you, Emma. And another really important point. So innovation and technology, the development that Emma was talking about, that's of course really important to us. But another really important topic is sustainability. And to just be very clear, to tackle the global challenges that we have today with climate change, human rights, health, inclusion, etc., we need to have a stable, resilient and safe society. So from that perspective, we work with providing that safe foundation, so to speak. But then we also work with quite a lot of different initiatives. Every year, when we do our strategic business plan, we look at the UN sustainability goals, and we look at the synergies and what we can do that can provide the best benefit and the most change. We focus on making sure that we have business conduct that is globally very sustainable. We also work with different initiatives when it comes to developing innovation from a sustainable kind of perspective with our partners and customers. So we have, for example, been flying our fighter jet Gripen on biofuel, which is basically rapeseed oil, and that's worked brilliantly. That's the type of projects we're kind of focusing on. We also have been working on something called science with science-based targets, and we joined the UN's Race to Zero campaign. So the two projects today that we're going to talk about, I'm going to specifically talk about a project. I couldn't help it, right? We were talking about space today, so I need to speak about a very exciting space project that I've been working with, just to give you a little bit of a taste what type of technology and what type of capabilities we can be together building.
Yes, and I will talk about continuous enhancement and technology development through our Giraffe-1X radar and how that system is used to detect drones, among other things.
So let's start to talk a bit about space. So I'll give you a really fast nutshell background. We're going to go through hundreds of years here in just half a minute. But humans, we always had this quest to look towards the stars. We've started basically from the beginning of time with astronomy, following the stars. We came into the 1900th century, and then there was a space race between the US and USSR that actually drove a lot of the space development that we see today. Including in that space race, we also saw human space flight. We saw the Apollo program that put people on the moon for the first time. And we saw the kind of development of the space shuttles come and go, basically, because then the program was kind of discontinued. And our first Swedish astronaut, Christer Fuglesang, he had the opportunity to travel on those. The last couple of years, the specific focus has been on the ISS, the International Space Station, and the fantastic international collaboration that's been done between different countries in the world to support the space station and also to do quite a lot of really interesting science up there. And now we have new space, and new space, you could define that with that we have now companies, commercial business coming in, working with the space domain. It used to be funded by governmental money, very much focused, for example, from the space race, old times when governments were kind of funding. There's still a lot of governmental funding, but there's also now commercial interest or commercial business to be done, and there are commercial investments. And there's a lot of value going into this space, if I may say so. McKinsey and the World Economic Forum, they came out last year with a report saying that they valued the space sector to $630 billion for 2023. And they value the space sector for 2035 to $1.8 trillion. So there's a lot of expectations now also that space as a domain, as a kind of a business kind of place for development and business will grow. But not only in space, actually mainly on Earth, because there will be all of these services and kind of solutions on space that will provide lots of really positive things for us people, and that will be space-based, but they will provide value on Earth. So a couple of words about defense then, because space also has a growing importance for defense. And we talk most commonly in four different on four different groups, areas where this is really important for defense. One is SDA, Space Domain Awareness. And that's when we're looking upwards to space to understand what's above us, what type of satellites or what type of vehicles are kind of circling above us to understand who's watching us or listening to us. Then it's ISR, and that's really the opposite. It's intelligence, surveillance, and reconnaissance. That is to then look down and understand what is your opponent doing. Are they moving troops? Do you see assets that's kind of maybe moved or kind of that's new? Then you have P&T, which is also really important, and something that used to be a defense invention, but it's now in everybody's pocket, basically. It's the GPS, it's the position, navigation, and timing that helps you when you're going to use your Google map to find a way around town. And then last but not least, you have SATCOM, and that's communication, but you're just using satellites as platforms for that communication. And at SAAB, we're not a space company, we're a defense company. So we see this value that space can be bringing, so we can enhance the products that we're working with, and that we can also make sure that our customers can use this type of capabilities, as we call it. So that was very briefly about space. So now I'm going to talk about a really interesting project that I've been working on for the last couple of years. And it brings together these kind of thoughts around innovation, sustainability, and also about taking a product that we're working with and have been working with for a very long time and enhancing it with space capability, so to speak. So now I'm going to talk about something called AIS. AIS stands for Automatic Identification System. And it's a transponder telling everybody that can pick these up where you are. And it's something for the maritime industry or for the maritime domain. So basically, if I have a transponder, an AIS transponder, it tells everybody that can see me then that I'm here. And then if Emma, she has an AIS transponder with two ships in the night, she sees me and I see her. And this is the reason, or it's a safety application that makes sure that we don't collide if it's dark or misty or the weather is bad and so forth. These can also be hugely useful in ports where there's lots of traffic. So we're looking now to the new generation of AIS, which is called VDES, which stands for VHF Data Exchange System. And this is not just a transponder telling everybody where you are, but it's actually a communication system. So what you can do is that you can do communication with it. And we're already shipping this now to ships and to ports. But this is something now that we're also looking to develop into space application. And I'll talk a bit more about that. So the very good thing, of course, with a kind of a radio like that, or a transponder that can work like a radio, is that it can communicate. So not only can we tell each other where we are, we can also convey messages. We can warn each other when it comes to icebergs, or we can maybe have weather forecasts, or we can do lighter type of communication, or IoT, as you all know very well. And this VDES has 32 times more bandwidth with AIS, which makes it much more useful. And what we've done now, and this is the kind of project that I've been working with, is that we've taken this VDES transponder and put it on a satellite in something called IOD. It's an in-orbit demonstration. So we sent this transponder, or this radio, up on a satellite. The satellite's name is Ymir-1. It was kind of launched from California in November 2023. And it's been extremely interesting, and we've been testing it now for quite some time, and it's been, from my perspective, a huge success. We've not done this us only as SAAB. We've done it together with AAC Clyde Space, which is a Swedish-British company, and Orbcom, an American company. So we've gone together in a consortia to do this. And this is what you now see. These are the superhighways of the sea. And what you see here on this map is data from Ymir-1, the transponder. And all the green dots are AIS transponders. So here you see there are merchant ships, navy ships, yachts, aids navigation like fish farms. And the Ymir-1 transponder has been picking up all of these vessels. And this is, of course, a space capability that's really interesting. And one satellite will not make a system, but if this is a first step towards a system with several VDES transponders in the air, you'll see how, or in space, you'll see how this can be really useful tool for safety all around the globe. Because with the satellite and the kind of VDS transponder on the satellite, you'll get the beyond horizon kind of view. It's a very important kind of voting coming up at something called the IMO, the International Maritime Organization, here later during the spring. AIS transponders are mandatory for ships or vessels over 300 gross tonnage, or international ships that carry passengers. And the voting is around if they also are going to make VDES then basically mandatory in a similar fashion like AIS is today. And that, of course, will make a really big difference for maritime safety. So coming back also to the sustainability point. So this is a good example where we looked at a product that we've been working with for a long time. We looked at technology development and innovation. And we also now see what type of impact will this have on the globe. And we'll compared with what we're doing with the UN sustainability goals. And this will be a global system that will be not only efficient, you will be able to optimize shipping routes, save fuels, save emissions. You'll see autonomous ships perhaps in the future. There'll be more efficiency, you'll see growth, and there are lots of really positive effects of this type of technology. So I'm very excited about this development, and I hope you are too. And now I'm going to leave this over to Emma. She's going to talk about another very exciting project.
Yes, we have now been up in the air looking down at Earth, and now we will change the perspective. We will stand on Earth and look upwards. The world is changing, a new reality is emerging, and with that comes new threats. These threats can be drones, many drones closely together. These have to be detected early, and this drives the need for new radar performance. We need radar systems that are mobile so that they easily can be deployed at different sites and moved. We need radar systems that are versatile, so depending on where they are used, they can have different functions. And we also need systems that are upgradable, because what is happening is that technology is moving very quickly now. So we need to follow that and be able to deliver new capabilities to our customers. And this we at SAAB can do through the Giraffe-1X radar system. So I will spend the next 10 minutes talking about the systems, explain a little bit how it's used to detect drones, and also what technical challenges that implies for us. You can see the Giraffe-1X behind me on the screen. Here it's put on a Jeep, so it's quite small and lightweight. This radar is used for situational awareness in the sky and on the surface. So it rotates 360 degrees, and during that time it detects, tracks, and classifies targets or objects in the air. So it helps us to actually see what is out there in the airspace. And as I'm standing here speaking to you right now, this system is used around the world. And one of the things it's used for is to detect the drones. This system consists of standardized hardware. We call it military off-the-shelf. This means that we can produce the hardware and keep it on stock. And this makes us be able to reduce the delivery time. Before it could take years to deliver a radar, now we're down to months. And in the current situation we're in, that's really important. With this, we also have a lot of capabilities in the software, which means that we can provide software upgrades to our customer and enhance the performance of the system during its lifetime. Currently, we have 3 different software versions: land, sea, and land RAM. So depending on where the radar is used, we can configure it with different software. So if we are to change how we use it also, then we can configure it with new software. So then, let's look at drones. Why are drones of importance? Well, drones is becoming an evolving threat, both in the military. We see that this has been used a lot in the tragic war in Ukraine, for example. We also see that drones are more and more used in civil settings. Drones are used to sabotage or disturb critical civil infrastructure as well. So for the military and other users, it's becoming more and more important to be able to detect drones very early. Military radars like the Giraffe-1X has traditionally been designed and developed to detect targets like airplanes, the fighter jets, helicopters, and missiles. Drones have other characteristics, and that makes them more difficult for a radar to see, and that creates some technical challenges. Some of the characteristics that makes them more challenging to detect are seen behind me. They are low flying. This means that the drones often fly close to buildings, trees, and other surroundings, which makes it difficult to see the drones among all the other things. They're small as well. If compared to a huge aircraft, the drones can be very small, and that also makes it more difficult to see them on a distance. And they fly slowly. Compared to aircraft and other things, a lot of the drones fly very slow. And traditionally, slow and small targets have not been of interest, so there's been filters in the radars that has discarded this data directly. But when drones now are moving slowly, we have to analyze and use that data as well, and then that demands more computer power and signal processing. So, as I said, detecting one drone is a challenge. Then imagining there being hundreds or thousands of them. Behind me now you can see a radar picture. This is how a radar interface can be presented to an operator. You see a lot of black objects in the picture, and there are some yellow as well. In this presentation now, in this graphical presentation that the operator could see, you see both birds and drones. If you as an operator get this picture, it's very difficult to use it. It's difficult to make sense of what targets are important for me to follow or to act on. So a very important and essential task for this radar is to be able to separate what is a drone from, example, birds and other targets. So, our engineers have developed a drone tracker function. The drone tracker function can detect, track, and also classify a drone. So it can, for example, say, is it a fixed-wing drone or a rotating one? It also has an operated operator presentation threshold, which means that the radar helps to filter away all the targets or objects that is not of importance. So here you can see this radar operator picture is something different. Here you can see the drones very clearly, and all of the birds that are irrelevant right now is removed. This is a very simplified picture, but this is very important. Imagine when there are hundreds of drones as well. It's essential for the radar to be able to very quickly identify what are drones and other important targets and what is irrelevant information. So, because of this, the signal processing is at the heart of the radar. It needs to handle all the radar data that is collected, it has to make sense of it, and then together with the tracking present the information in a valuable way and ensure that it's only the targets of interest that is visible to the operator. And since the development of targets is going very quickly, drones are behaving more and more like birds, and also with the recent development in radar technology, the processing performance is becoming increasingly important. And this is an area where we are working a lot to see how can we increase the performance in the system, how can we ensure that we can process the data and present it on a shorter time and more precise, because time is of essence here. We want the operator to get the information as quickly as possible so they can act on it. But when working with the signal processing, there are of course other constraints as well. The signal processing within the radar is embedded, which means that if we are to improve it or enhance it, we need to make sure that it still fits in the same hardware structure. Weight, as you saw, this system can be implemented on a jeep. It can also be implemented on a ship, which means that weight is of essence as well. We cannot do enhancements that goes out of the weight. Power as well is one area that is important, because the available power is limited. So we have to ensure that we use the power very efficiently throughout the system to optimize its performance. And cost as well. That's always a factor, that we must see that the cost of the system is in relation to the value it provides. So at SAAB and at PU Giraffe-1X, we work very closely, cross-functional, to develop these systems, to ensure that we understand dependencies within the system. So if we do changes in one part of the system, how does that affect other ones? Also, what and where should we compromise to ensure that we have a performance that is good enough today, but also that can develop over time. So we're quite a small R&D unit. We're around 200 engineers in total working with this. So we work very closely together to constantly improve the systems and be able to deliver new capabilities to our customers. And just to finalize, I would like to share one proof of concept that we're also doing with partners, because that is one important part for us as well. We are very good at microwave technology and sensors and radars, but we also need to collaborate with other people and other companies that have competences that we do not have at the same time. So we recently did a proof of concept with NVIDIA technology, where we changed from CPU to GPU-based systems. So we did the test on the Giraffe-1X system, and we could immediately see an improvement of the processing performance. We could see that we could do it with less resources, so we could reduce the number of process boards, and by that also decrease the complexity in the system. So this is something that is really interesting, that we will continue to investigate and see how we can implement in our systems going forward. So this is just one example of how we interact with partners as well, in order to ensure that we bring new technologies into our systems and that we are prepared for the technology that is coming ahead as well. So with the new reality, we see a need to be able to deliver radar system quickly, and also then to be able to improve their performance over time as technology evolves and also threats evolves. And we also see that we need to be able to increase our processing performance, and the compute needs will only increase going forward. So we need to innovate and see how we can continue to work with that, both internally and with partners.
And Emma, also, I mean, what you're describing right now, it's very much software driven also compared to how it used to be in the defense sector, just in the same way as it's in the civil sector, much more software driven.
Yes, yes. Now we see the technology shift is going faster and faster, and the only way to be able to deliver new capabilities and meet those development is to do it through software. So our products is becoming much more software driven now than they were 10, 15 years back. Good, so let's try to summarize this. We have talked a little bit about different technologies that we are working on, how we collaborate both internally and with partners to ensure that we always keep ourselves innovative and that we develop our products. We also see that going forward it will be increasingly important to work with system of systems and work with system across domains. System on land, on sea, in space, must be connected, and they must be able to share the data so that we get the complete system view.
And I hope you'd thought, looking at these two presentations, we had my presentation, which was very much a commercial project. It was about maritime security, so it was safety and security. And Emma's presentation, which was more about one of our really important military applications. I hope you found that interesting. But now I want to come back to the question that I asked in the beginning, and that is, Emma, so what drove you to take this career path? And what makes you get up in the morning and think that this is something that you like to do day in and day out?
Well, I started at SAAB 13 years ago, directly from university. It was just a coincidence. When I started at SAAB, I was brought up with SAAB cars. So when I entered SAAB 13 years ago, I still had the cars in my mind. And at that time also, I Googled SAAB. I'm based in Gothenburg, so I work at the Gothenburg office. When I Googled SAAB back then, I couldn't find any information. It just said, we work with defense, . It was very secret and hush, hush, we didn't talk about it. So a lot of things has happened just the last 3 years. We're actually talking about defense, and we're here today. We wouldn't have been in this stage 10 years ago. So it was a coincidence that I ended up at SAAB, but I have really enjoyed the time. I've always liked problem solving, and I think at SAAB I really get to work with problem solving, technology problems. But I'm also very fascinated that we do these very high technology products, but they are developed and produced by people. I'm still surprised how much it is actually our brain, our collaboration, our problem solving that is actually creating this really cool technology. So yes, I'm really into cool technology, and that's why I like this. But I also like it that we work very closely together. We collaborate very much, and we're quite a small company in order to be able to produce these kind of systems. So I believe that I get a lot of mandate and responsibility and can drive my own ideas as well. So that has made me stay. And more recently also I see a purpose in this. I have small kids myself, and it becomes evident now, unfortunately, that we can't take a democracy for granted. We need to be able to protect ourselves. And that's why I feel that now more than ever we have an important part in society as well in be able to protect ourselves if that becomes needed.
Well, thank you, Emma. And from my perspective, my purpose, the reason I go to work is very similar, even if it has a bit of a different path. So from my perspective, technology development is very much about progress. I'm a big fan of Hans Rosling, for example, that kind of measured the world in health and wealth and could show how we got both healthier and wealthier all over the world in every country over when time kind of went by. And from my perspective, I see technology development playing a crucial part in that. And I completely agree with you that also with the geopolitical uncertainties, it kind of gives you the motivation to also come and contribute to work on a daily basis. So, and my thinking here is also that if you'd like to talk to Emma or myself afterwards, we have a couple of more minutes when we end this, but otherwise we're going to just be outside down the staircase. if anybody wants to talk to us. We also have a couple of colleagues, if you want to just raise your hands in the here. So we have 2 colleagues there, and then we have Lynn, she was up there. So we will be afterwards if anybody wants to speak with us, and if you'd like to, in more quiet kind of terms, go in and look at saab.com/career. You're most welcome to do that, to see if there are any opportunities that might suit you. One of the things that I also was kind of reflecting on was that I'm so proud of everybody here. My grandmother used to be a math teacher, and my father's sister used to be in the IT business in the 1970s. Can you imagine? That was women in tech in the 1970s. It wasn't a lot of women back then. So I'm very, very proud of being here and very happy to be speaking to you. But if you'd like to keep listening to a colleague from Saab and also to hear more about space, please join Markus Wandt, former chief test pilot of Saab and now chief innovation officer, because he's going to be on the stage at 3:30, the main stage, and talk about technology development and other exciting things. I'm sure he's going to mention space. What do you think, Emma?
Yes. Maybe in the background just a little bit.
Well, thank you so much for taking the time and that you joined us, and have a fantastic the rest of the day here at Women in Tech. Thank you.
Thank you.